Good evening everyone. Welcome to the lecture Machining Technology. So we are discussing analysis of orthogonal machining. So in the last lecture we have discussed the velocity relationship, the relationship among VC, VS and VF. So what is VC? Cutting velocity, VS is shear velocity, VF is chip flow velocity. And we have solved some problem in our regular class also. So next we are going to discuss the derivation for shear angle. So why you want to derive the expression for shear angle? Because in the last class I have asked, is the shear plane is fixed or variable? So yes, the shear plane is a variable. So here the shear plane is nothing but a shear region. Shear region means where shearing is taking place. Shearing means the plastic deformation. So as it is a plastic deformation, so it depends upon your workpiece material, what type of materials we are using during machining, and how much velocity we are using, what amount of velocity, cutting speed, and the tool signature. It depends upon the tool signature also. So to find out that what are the factors which vary your shear angle and shear plane, because if shear plane will variable means the shear angle also change. So if you know some expression for shear angle, then we can confirm that okay, these are the factors for that the shear plane is varying or shear angle is varying. So let's start the derivation. So again we have taken the same model, a machining model. A tool is removing some amount of material from the workpiece, and you can see here the gamma is your rake angle, which is with the vertical plane, and then the cutting this rake surface of the tool. Beta is the shear angle, which is between VS and VC, and this is the machine surface. After machining, this is going to be machined. This amount of material, that is T1 uncut chip thickness. This is the chip, that is cut chip thickness, and 3 velocity VC, VS and VF. So for derivation we have only taken this portion of this figure or of this model. So we have zoomed in this portion, so it looks like this, and again we have shown the angles, that is gamma. Gamma is your rake angle, which is already you can see here, and beta. Beta is the shear angle, which is the angle between VS and VC. Next we have given a name A to this point, B to this point. So why we have given like this? Because from B point we are going to draw two vertical lines, one from B to C, another one from B to D. What is C? C is a point on where? On this machine surface, or the surface to be machined. On this surface a point C. So from here to here, that is BC, and D. D is a point on the rake surface. So from B to D. So this is the rake surface from B on to D. So D is on the rake surface of the tool. So BD and BC, two lines we have drawn from the point B. Here the angle between BC and BC and AC is 90 degree. Angle between BD and AD is 90 degree, because those two lines are vertical lines. So if we consider this is blue color, that is vertical axis, and this AC, this angle between AC and this line is 90 degree. You can see on video that this angle is, total angle is 90 degree. So angle CAB is already, it is angle beta, that is shear angle, angle CAB. So what about this portion? How much the angle? 90 minus beta. Total angle 90 minus this angle, that is beta. So this amount for this region the angle is 90 minus beta. And what about the small one? That is gamma, which is already you can see from the here. So the total angle is angle DAB. DAB is how much? 90 minus beta plus gamma. Angle DAB is 90 minus beta plus gamma. So here again this line BC, the length of the line BC is how much? BC, you can see it is parallel to the thickness. Which thickness? The uncut chip thickness. So BC is nothing but T1. Here BC, so this is T1. Likewise BD, it looks like parallel to the chip thickness. So BD is nothing but T2. So BC is T1, uncut chip thickness, and the length of the line BD is T2, that is chip thickness. So now we have, you can see here two triangles are formed. One is triangle ABC, and another one is triangle ADB. So two triangles, two right angle triangles, you can see here, triangle ABC and ADB. So you can see here the same model, whatever we have derived till now. ABC, ADB. So if you consider triangle ABC, what is sine beta? Sine of this angle is sine beta, which is sine beta equal to the perpendicular, that is BC by hypotenuse, that is AB. So BC by AB. Sine beta is equal to BC by AB. What is BC? BC is T1. So sine beta is equal to T1 by AB. Next, what is AB? T1 by sine beta. If we arrange, then you will get AB is equal to T1 by sine beta. Likewise, if we consider second triangle, that is triangle ADB, if you consider triangle ADB, then what about this angle? This angle is 90 minus beta plus gamma. Triangle DAB, 90 minus beta plus gamma. So sine of 90 minus beta plus gamma equal to, again in the same way, the perpendicular, that is T2 or BD by hypotenuse, that is AB. Sine of 90 minus beta plus gamma equal to BD by AB. BD by AB. What is BD? BD is T2, the curve thickness. So T2 by AB. Next, if we arrange, what is AB? T2 by cos beta minus gamma. Why it is cos beta minus gamma? Sin 90 minus theta. If we arrange like this, then sin 90 minus theta is cos theta. So cos beta minus gamma. So here also you will get one expression for AB, it is T1 by sin beta, and here also that is AB T2 by cos beta minus gamma. Now if we equating both the expression of AB, then T1 by sin beta is equal to T2 by cos beta minus gamma. T1 by sin beta equal to T2 by cos beta minus gamma. So now if we arrange T1 by T2, just take T2 to here, T1 by T2 is equal to sin beta by cos beta minus gamma. Sin beta by cos beta minus gamma. And already we have derived for what is T1 by T2, that is nothing but your chip thickness ratio R. So T1 by T2 is equal to R equal to sin beta by cos beta minus gamma. What is sin beta? What is cos beta minus gamma? If we expand this one, cos A into cos B plus sin A into sin B. So cos beta into cos gamma, cos beta into cos gamma plus sin beta into sin gamma. So just write like this: sin beta divided by cos beta into cos gamma plus sin beta into sin gamma equal to R. Now divide cos beta in both numerator and denominator. If we divide cos beta, sin beta by cos beta, cos beta, cos gamma divided by cos beta. So cos beta will cancel, and you get cos gamma here, cos gamma plus sin beta into sin gamma divided by cos beta. So sin beta by cos beta will become tan beta into tan sin gamma. tan beta into sin gamma. So the expression will convert to tan beta divided by cos gamma plus tan beta into sin gamma, which is equal to r. So simply we have divided cos beta in the numerator and in the denominator. So now if we arrange the tan beta and find out one expression for tan beta, or for solving for tan beta, then tan beta will become equal to r cos gamma divided by 1 minus r sin gamma. Then what is beta? Beta is tan inverse of r cos gamma divided by 1 minus r sin gamma. So here r is your chip thickness ratio, gamma is the back right angle, and if you have to find out the shear angle, then simply you will take tan inverse of r cos gamma divided by 1 minus r sin gamma. So from this expression also you can know that beta is proportional to your r and also the gamma from the tool signature. So r is the ratio between uncut chip to the cut chip, so chip thickness. So if we change r, then the angle beta will also change and the shear plane also change. Likewise, if we change the gamma, the value of gamma, that is gamma b, also we can change the shear angle, shear plane. So the shear plane will depend upon your chip thickness ratio and your tool signature, that is your back right angle, and the workpiece material, and as it is chip thickness ratio, so we can relate to the cutting velocity, because chip thickness ratio is Vf by Vc. So in that way, the shear plane vary with by changing the following factors. The following factors: your chip thickness ratio, cutting velocity, workpiece material, tool signature. So these are the parameters which will change your shear plane or shear angle. So in the next class we are going to discuss how to calculate the induced force, the force induced during the machining operation. So thank you.